So in my previous lecture, we started with the concept of switching. Then we looked into what actually switching is, how does this switching happens in the form of various steps, and we looked into the functionality of switch in detail. Considering the types of switching, we have looked into we named there are three types. One is message switching, circuit switching and packet switching. And in my previous lecture, we have seen message switching in detail along with its key characteristics, advantages and disadvantages. So, message switching basically a highly inefficient kind of obsolete method which is store and forward. Each and every message is going to be stored at each and every node and then forwarded by that particular node. So, although it is having some advantages, but more of disadvantages considering higher latency, congestion and complexity in reassembling and so on and so forth. With that background, moving on to circuit switching. Circuit switching says it is a type of switching in which a connection is established between the source and the destination beforehand. Beforehand as in before the starting of the original actual communication. So, this connection which is being established receives the complete bandwidth of the network until the data is transferred completely. Now, this message, this approach when compared with message switching, it does not involve sending data to the entire network. Rather than it is focused on sending the data only to its intended destination. So, here if you can see, we have a figure in which there are messages, message 1, message 2, message 3, and rather than sending all these messages onto each and every node which are kind of storing and then forwarding that particular message, or we can say all of the messages, which are intended for the node B are sent to only to the node B, and then they are following a kind of, we can say, a connection or a path, and that path here in this figure is going from A to P1, then from P1 to P2, P2 to P4, followed by P6, and then directly connecting that to B. So, this is the path, or we can say this is the connection line which is being used in this example of circuit switching. So, circuit switching, when we talk about, we have seen that a dedicated physical or it could be logical path is being set up between the source and the destination nodes before any data is transmitted. So, this connection will remain active for the entire duration of the communication. Now, if I want to compare this kind of technique with one of the we can say communication functionalities, it is kind of making a phone call to a friend. So, you take up a phone, dial a number, and then that connection being established, and that connection is dedicatedly kind of available for this particular purpose, or for the purpose of communication between you and your friend. So, this kind of application is based on the techniques of, we can say, circuit switching. So, here what are the key characteristics of this circuit switching techniques? One is the bandwidth is guaranteed because there is a dedicated connection, and transmission quality will be kind of consistent because that that particular line or that particular connection is not being kind of, we can say, given to anyone else. Now, nodes remain dedicated to the connection throughout the session. That is the particular property of your circuit switching, and it is best time for which type of best suited for which type of applications. So, your circuit switching is best suited for all those applications which requires real time continuous data flow, like as I have given you an example, which was kind of in traditional phone calls. So, traditional phone calls were based on this circuit switching technique, in which there is a dedicated channel on each link which is used by each connection, and also each link can be divided into n channels by using TDM or FDM. So, TDM stands for time division multiplexing and frequency division multiplexing is FDM. Now, we will be definitely looking into what is TDM and what is FDM technique. So, when I am saying that there is a dedicated kind of link for one particular connection, that may that may lead to a discussion that this could be a wastage of the entire bandwidth when on a particular link there is only one channel or there is only one connection which is being set up. There can be others also, because one connection may not be able to take up or may not be able to use the whole bandwidth. So, one way it is fine, it is right that we are giving a dedicated channel, fine, a dedicated link, but that link also can be divided into different channels in order to have we can say some multiple communications going on that in going on in that link. In this way we will be able to utilize these the whole link in a more optimized way, we can say. So, again there are disadvantages and advantages of circuit switching also. So, if we look into some of the disadvantages of circuit switching, we can say the first disadvantage is it is inefficient for data traffic, because there is a dedicated path and that dedicated path is always available even during the periods of no transmission, making the utilization of the available resources quite inefficient. And because of this inefficiency, there are techniques like FDM and TDM which we are going to discuss, so that this whole dedicated path can be used in a more optimized way. So, there is a dedicated path, that means there is a call which is going on between you and your friend. I am talking about a traditional phone call here, please remember. And let us say you are not speaking, or data is not being transferred, you have gone somewhere else and held up the phone like that only. So, that this is a kind of a wastage of resources, because in that particular time no transmission is happening and utilization of that particular line is not happening. So, and this is kind of a very common situation in case of data traffic, because every time a data is coming on, that could not be a situation, there can be some lean periods in between. So, whenever there is a dedicated path always available even during the periods of no transmission, obviously your utilization of that particular channel is inefficient, it is going to it is not up to the optimum. Then of course, there is a setup delay which was not there in message switching, which we talked about. Setup delay, if we talk about, it is about creating the connection, involves some form of configuration during which some amount of time may be taken. So, when we compare this with a traditional phone call, so obviously you need to dial a number, then the call or the request will go to the receiver, and then there is a connection is established, then your receiver is going to take the phone call. So, that setup process is going to take is going to eat up, we can say, some amount of time. So, creating the connection which involves some form of configuration which will require some time. Then we have the bandwidth, which is cannot be changed dynamically as per its need, which is the bandwidth which is allotted, or we can say it is allotted or it is subscribed beforehand. So, it cannot be changed dynamically as per the needs of the communication or as per the needs of the traffic. So, that means the bandwidth which is being subscribed or which is being reserved is fixed. So, again that is disadvantage. Looking on the other side of the coin, coming to the advantages of circuit switching, the connection, as I have told you, is dedicated. So, it gives a guaranteed availability of bandwidth, which is going to decrease the probability of proactive failures in connections. So, in form of kind of we can say, if we talk about reliability, yes, because of this dedicated connection, your circuit switching is kind of an we can say an preferred option. Moving further into the advantages, real time communication, if I am talking about, which needs low latency. So, that communication is an application scenario for circuit switching. So, for example, it is a good candidate if you want to make a real time application such as a voice call or something. So, circuit switching is perfect. When we talk about reliable data communication, once your line is dedicated or once your circuit is being set up, there is, we can say, kind of a very little intrusion or even no intrusion, and hence there is a minimal risk of loss of data. So, considering the advantages, good for real time communication, for real reliable data communication, circuit switching is also a candidate. Packet switching, this technique requires the data to be broken down into some smaller components, like it could be a data frame or even it could be a packet. So, these data frames are then transferred to their destination according to the available resources in the network at a particular time. Now, this is a kind of key point which is going to separate your packet switching from other two techniques of circuit switching and message switching. That means the data is being transferred to the destination according to the available resources in the network at a particular time. Now, even your modern computers, even your the biggest network, which is the internet, uses this technique of packet switching, because message switching and circuit switching are having their own kind of we can say consequences. In circuit switching, we can say there is always a dedicated line, whether and that dedicated line is being held up even in the periods of no transmission, we can say. Also, message switching is kind of flooding each and every node with all the messages, which is also not a good idea. So, your modern computers, your internet as a network is going to use this packet switching as the kind of used switching technique. Here, each data frame contains additional information about the destination and some other extra information which is required for the proper transfer through the network components. And if we talk about how does it happen, this data is broken down, the whole data traffic or the whole incoming data is broken down into a small fixed size unit called packets. Each packet is having its own destination address and is routed independently across the network, and that this is also kind of very important, that each packet is routed independently across the network, and that we can see here with the help of the figure. If we can see, there are kind of two computers which they are in communication with each other, and a message which is having kind of four frames, or we can say four packets A, B, C, D, and at one particular kind of node, which is the S1. Now, A and D are taking a different path, while B and C are taking different path. From S1 to S2, A and D are being transferred, then D is transferred to S3, while your A is transferred to some other node. So, what is happening here? So, here if you can see, all these packets are having their own destination address, and they follow whichever path is kind of available to them. So, whatever available path is given to a particular packet, or whatever available path is being found out by a packet, that packet will take that particular path, and if that path become congested, the the packet which is coming behind will not take that path if it is not preferable. So, my point here is each and every packet is may take a different path depending upon the availability, and hence we can say the efficiency is kind of maximized. So, a network path, if we talk about the key characteristics, we can say the network path can be shared among many users. Packets may take different routes to reach the destination, and this is what we can say a bottom line or a punch line could be here. Now, if you remember the packet switching, that packet switching was again divided into two parts. One is the datagram packet switching, another one is the virtual packet switching. So, let us see although these two types in detail. So, in datagram packet switching, each data frame is taken as an individual entity and thus they are processed separately. No connection is established before data transmission occurs, and this is in contrary to the technique of circuit switching, in which there was a dedicated path which is established beforehand when your data transmission is going to occur. So, there was a setup delay, then there was kind of a transmission phase, and then so on and so forth. Although this approach provides some flexibility in data transfer, it may cause a loss of data frames or late delivery of data frames. So, let us try to see how this happens. So, for example, there are 4 packets 1, 2, 3, 4 which is started, those who have started from one particular node, and then they have taken different paths, and on one particular path, let us say packet number 2 is kind of being lost, and at the receiving end there are only 3 packets which are being received. It is packet number 1, packet number 3 and packet number 4. Now, what will happen? We need to retransmit this packet number 2 in order to have a message, in order to have a complete message. So, this approach may create or may cause a loss of data frames, or it could be late delivery of the data frames. Now, let me explain the late delivery of the data frames. So, all those 4 packets 1, 2, 3, 4 have taken different paths, and packet number 3 is on a path which is kind of, we can say, congested or having a huge traffic flow. Now, what is going to happen there? Packet number 1 and 2 and 4 are arrived at the kind of destination well in time, while packet number 3 is still somewhere in on the route. So, at the destination end, the system has to wait obviously for a specific time, because the system is not aware that whether it is on whether the packet is en route, or we can say the packet is lost. So, for a specific period of time your system is going to wait, and if within that particular time your packet number 3 is going to arrive, then the whole message will be formed, and if it is not arriving or if it has not arrived within a certain period of time, then a retransmission request kind of may be created or may be given. So, it could be loss of data frames, or it could be late delivery of the data frames. Apart from despite of this whole flexibility in data transfer, your packet switching, or specifically if I am talking about datagram packet switching, this is going to have this situation. Moving on to the next type, which is virtual circuit packet switching. Now, circuit switching we have already seen. Here it is virtual circuit packet switching, which is one of the subtypes of packet switching. So, in virtual circuit packet switching, not a physical but a logical connection between source and destination is made before transmitting any data. Please recall circuit switching. In that circuit switching, the connection was, it could be more of a physical connection, but it could be a logical connection. Here there is no question of physical connection, it is always a logical connection, and these logical connections are known as virtual circuits, and hence the name virtual circuit packet switching. So, this in virtual circuit packet switching, logical connection is established between source and destination before starting of the transmission, and each data frame will follow that logical path, and hence this provides a reliable way of transmitting data with less chances of data loss, because in the previous techniques or in the previous sub technique, which was datagram packet switching, the major issue was the loss, data loss, if we can say. And if we want to avoid that data loss, we need to kind of avoid the packets moving on to the different channels or different connections, and because of that a logical connection is being established between sender and receiver, and hence we call this technique as virtual circuit packet switching. Now if we talk about all the three switching techniques, which are message switching, circuit switching and packet switching, and if we want to kind of we can say compile all the differences between these. So let us try to look into the differences between message switching and circuit switching. So circuit switching, as I have told you, there is a physical path between the two systems, while in message switching data is first stored on one node, forwarded to another node, transferred the data. In this way the data is being transferred onto the the whole system. In circuit switching, data is not stored, there is no concept of storing the data, while in message switching the data is first stored and then forwarded, and hence the name is store and forward technique also. Circuit switching needs a dedicated physical path, and that is why messages need not to be addressed, because that path is from a sender to a receiver, and all the messages will obviously will be kind of delivered to that particular receiver, and hence specific address is not needed. While message switching, if we talk about, there is no concept of a dedicated physical path, and hence the messages are needed to be addressed in an independent manner. Moving further, we can say your circuit switching is geographical addressing, while your message switching can be seen as the form of hierarchical addressing. Circuit switching is costlier than message switching, obviously, because we are kind of dedicating a particular path, and here the cost of data transmission in message switching is obviously lesser than the circuit switching. Now circuit switching routing is kind of a manual type routing, while message switches routing is not manual type routing, and hence the route is selected during call setup, we can say. Circuit switching, if we talk about, it receives the full bandwidth in advance because of this dedicated connection, because there and hence because of this there is a lot of wastage of bandwidth. Now the question here arrives that what is to be done in this case, and as I have already told about the bit of the solution, which is time division multiplexing and frequency division multiplexing, which obviously we are going to cover in our upcoming lectures. So circuit switching receives the full bandwidth, and hence there is a wastage also. Message switching does not reserve the entire bandwidth in advance, and that's why we can say bandwidth is used to its maximum extent, although message switching is having its own we can say disadvantages. In circuit switching, the change depends on the time and the distance, while in message switching the change is more based on the number of bytes and the distance to be covered. Moving further, if we talk about the congestion in circuit switching, so kind of say we can say congestion occur per minute in circuit switching, while in message switching no congestion, or we can say a very kind of little congestion, because there are so many paths, and each and every packet is going on to each and every path. Circuit switching uses analog and digital media on a variety of platform, while your message switching uses only digital media on a variety of platforms. In circuit switching, there is no propagation delay, while there is a propagation delay in message switching. While if we talk about delay in circuit switching, setup time delay is there in circuit switching, while it is not there in message switching. Transmission capacity of circuit switching is low, and transmission capacity of message switching we can say is high. Uh, Also, in a circuit switching, messages need not to be addressed, as I have told you that there is a one dedicated path, while in message switching, messages are addressed independently, because these are going to be sent to each and every node, stored on each and every node, and then kind of forwarded. If we look into the examples of real time examples of circuit switching, so any real time transfer of voice signals, while message switching, the best example of message switching is transmission of telegrams. Now, comparing these two with the packet switching is kind of, we can say, is taking positives of all of these two techniques, and hence this is kind of used nowadays. It is used in the most advanced of the networks like your internet, because there is no kind of dedicated physical path, I can say, and then your whatever the packets are, those packets can can be routed independently. Because of this, yes, independent routing, this is required. Your addressing is definitely required. So in this lecture we started with circuit switching, and we also looked into the packet switching along with the key characteristics, advantages and disadvantages. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.